All right, so now we're going to talk about multiplying and dividing rational expressions. So, thus far, all we've done is we've been given one rational expression and we've been told to simplify it. Okay, so just simplify it within itself. Now what we're going to do is we're going to multiply and divide, which means we'll have more than one rational expression. We'll still use the concepts that we just learned and the concepts that you have embedded in your brain from elementary school and middle school. Okay, so all those things still apply. Multiply and divide rational expressions. So we'll start with one from elementary school. 3/5 times 10/9. You're looking for like factors that you could reduce. Now, one way we could do this, let's work this problem two ways, okay? So we could just use what we learned about the multiplication rule, which was when you're multiplying fractions, you do numerator times numerator and denominator times denominator. So this would be 30 over 45, and then we could reduce it. So 15 is the greatest common factor of 30 and 45. 15 goes into 30 2 times. 15 goes into 45 3 times. So this reduces to 2/3. Okay? We could use our knowledge of simplifying like factors in the problem before we do the multiplication. So you can reduce or simplify any numerator with any denominator when you are multiplying fractions. So if it was in this one fraction, I could simplify it just like I just did a few minutes ago. Or if it's crosswise, I can simplify it. Now don't say cross multiply, because that's not what you do on these problems. That's what you do when you have a proportion where there's an equal sign between two fractions. Okay? This is cross, I call it cross canceling. That's what we called it. Okay? So I'm going to cancel. 3 and 9 are both divisible by 3. So 3 goes into 3 once and into 9 3 times. 5 goes into 5 once and into 10 2 times. And then when you multiply numerator times numerator, denominator times denominator, you get 1 times 2 is 2 over 1 times 3 is 3. So you saved yourself a little bit of work didn't have to deal with some big numbers. Okay? I show you this problem from elementary school because, again, the same concepts happen in algebra. Okay? All the same techniques are always valid. So let's do one with expressions in it. 8ab squared over 7 8 times 21 over 3b to the third. Now remember what I said, you can simplify within the fraction, numerator to denominator, or you could simplify across any numerator with any denominator in the multiplication problem. Okay? So I might start with my coefficients. You might start with your A's. Somebody else might start with their B's. It doesn't matter. You're going to get to the same place as long as you do all of them. So I'm going to start with my coefficients. I like to start with the numbers first. So 7 goes into 7 once and into 21 3 times. And I really am bad about not putting the 1 when something goes into itself one time. So if I don't do that, don't freak out about it. It's just because I know 1 times anything is that anything. So it's really not a big deal. Okay? Then, what about the 3's? They cancel too, don't they? So numerator to denominator, so there is totally gone. What's left right here? A 1, right? And what's left here? A 1. Okay, now I'm going to go to my A's. So I have A to the first on top and an A to the fifth on bottom. So that's going to leave you with an A to the fourth on the bottom. Right? And then I have a B squared on top, B squared on the bottom, B cubed on the bottom. So B squared goes into B cubed and leaves you with a be the first, right? So I think I'm ready to write my answer. 8 times 1 is 8. Don't let me miss something. Over a to the 4th b. I believe that's correct. Do you think that's correct? Did I miss anything? Okay. I'm going to blame anything I miss on this bad angle up here. This is really bad, actually. It's very awkward. Okay, let's do one that's a little more difficult. So these were easy because there were no plus or minus signs in there. That's why it was easy, okay? When you get things added and subtracted in there, you're going to have to factor it, like we reviewed our factoring techniques Tuesday night. So we are on page 271 in the workbook if you have it. We're doing where it says video 2 now. So 6m minus 6n over 35n times 5 over m squared minus n squared. Lots of stuff happening in this problem. I see minus signs, tells me there's terms, so I've got to factor it. I've got to write these expressions as products. This is already a product, 35 times n. That's just a single factor 5, so those are already done really for me. So I need to factor this numerator, 6m minus 6n. What's their GCF? 6. Very good. So you pull the 6 out, and you're left with m minus n. And then you're going to write 35n right here times 5 over, this is special, difference of squares, perfect square minus perfect square. So it factors into the sum and difference of the square roots. So m plus n, m minus n. And then we can cancel any numerator with any denominator. So m minus n. What else do you see? Very good. 5 goes into 5 one time and into 35 7 times. I believe that is it. I'm going to write what I have left. I'm going to multiply across. So 6 times 1, that's just 6, over 7 times n times this expression, m plus n. There is nothing else that will simplify. That's it. Any questions? Okay. This one's a little bit of a challenge problem. But if you just came out of 098, I feel sure that you factored trinomials that look like that. Basically, the difference in this trinomial is that there's a variable on the last term too. So instead of just looking for factors of -6 and it being like -3 and +2 or whatever, you'll have n's attached to the ends of them. Okay, so that's the main difference. All right, let's factor. Let's just take it one at a time. I know it looks terrible. It's really a big problem, but we can do this, okay? One piece at a time. That's all you focus on. All right, so on the numerator here, what do they have in common? 3. So we're going to pull 3 out. See, that one was easy. In the denominator, what is their common factor? 12. So that's going to leave you with m minus 3n times. Okay, we're going to tackle it. So if that n wasn't there, if the n wasn't in the middle, so if there was no n here and no n's here, you would say factors of -6 that add to be -1 because that's the coefficient in the middle. And those are going to be -3 and +2, right? But because there's an n squared here, then that just means it's going to be -3n and +2n. So it will factor like this: m minus 3n and m plus 2n. Now if you FOIL that out, let's FOIL it verbally. You can go back and listen to it later. M times m is m squared. Do outer and inner. M times 2n is 2mn plus -3n times m is -3mn. And when you add those together, you get -1mn. Okay? And then -3n times +2n is -6n squared. So that is the way you do it. You just attach n's on the end. Okay? Down here, same thing. This one's pretty easy. Factors of 1 that add to be 2, 1 and 1, right? So that's going to be m plus 1n and m plus 1n. That's right. So if you FOIL that, you would end back up with this. I wrote the problem wrong. I'm sorry. That's supposed to have an m squared on it right there. If you wrote it with just an m, it was incorrect. Make sure you put an m squared right here where my pen is circling. Okay? I left it off. Now we're going to cancel. I notice immediately there's an m plus n in this numerator and 1 in the denominator. M minus 3n. These do not cancel because they are not exactly the same. Okay. What about the 3 and the 12? 4 in the bottom, right? So my final answer is, I got to look carefully, m plus 2n. That's all that was left in the numerator, so I don't have to put parentheses around it since there's nothing multiplied outside of it. And then 4 times m plus n. Can't cancel the m's because they have things added to them. Okay, so only if you could cancel the entire factor. All right, now let's talk about dividing rational expressions. So that was multiplying. Who remembers what dividing fractions was like when you first learned it? You change it to multiplication, right? So you keep the first fraction, you change the sign to multiplication, and you flip the second fraction, okay? That has not gone away. Those rules still happen with algebraic expressions in rational expressions. Keep, change, flip. I've had students come to me, KFC, they would say KFC, but it's really KCF, right? Okay, but anyway, they remembered it, so that's all that mattered. So let's do an easy one first. 3c squared over 4d divided by 15c to the third over 8. Are you Ginger? Okay. All right. So we're going to keep the first fraction. So don't cancel or reduce anything until you have done the process of changing it to a multiplication problem. So keep the first fraction. Change the sign to multiply and flip the second fraction. Again, there are no plus or minus signs in this, which is wonderful because now all we have to do is just freely mark things out, right? Just start crisscrossing. Okay, so 4 goes into 4 once and into 8 twice. 3 goes into 3 once and into 15 5 times. C squared goes into C cubed and leaves you with a C to the first. And I think that's it. If I miss something, I'll catch it in a second when I write this over. So 1 times 2 is 2 over 1 times D times 5 times C. So that would be 5CD. So what we do to write things in a proper form is we write our letters in alphabetical order if they're multiplied by each other, and our coefficient out front. So the number should go out front of the letters, okay? Does that look good? All right. So I'm going to give you one to do because we've done several multiplication problems. Division is just multiplication. You just have to turn it into multiplication, so you should be ready to do one. Y squared minus 8y plus 16 over 5y plus 35 divided by y squared minus 16 over 20. All right, so first thing we have to do is change it to a multiplication problem. So y squared minus 8y plus 16 over 5y plus 35 times 20 over y squared minus 16. Now, if you're already pretty proficient in this, then you probably went ahead and did some factoring there. And that's what I would do if I were working this problem. If you already got this down, I wouldn't rewrite this whole thing like this. I would go ahead and do some factoring. But whatever we need to do to make sure we don't miss it, then you do that. If showing every step is it, then do that. All right, in the numerator, factors of 16 that add to be negative 8. That's going to be minus 4 and minus 4, because negative 4 times negative 4 is positive 16, but when you add them, you get negative 8. In the denominator, you're going to factor out a y. I'm sorry, a 5. I said that wrong. Okay. Okay, factor out of 5 would leave you with y plus 7 times 20 over, and then y squared minus 16, you're going to factor as the difference of two squares, so it's y plus 4, y minus 4. And then you just start canceling or reducing, simplifying, whatever the word is that you like. Y minus 4 will cancel with the y minus 4 up here. It doesn't matter which one you mark out. The y plus 4 will not cancel with the y minus 4. They have to be exactly the same, and they're not. I do see that 5 will go into 5 one time and into 24 times. And I believe that that is everything that we can do. So let me write it down and make sure. 4 times y minus 4. Again, we write the coefficient in front of everything when we're writing multiplication expression. And then on the bottom, y plus 7 times y plus 4. And that's it. Any questions? Okay, we're going to look at another type of division problem in which it looks like a giant fraction with all kinds of fraction bars in it. So it's just going to look weird. Okay, so this is what it looks like. 2x over 5w over x squared over 10. This is called a complex fraction. It's fractions inside of fractions. So what you have to do, first of all, if you have to figure out is where is the main fraction bar? Well, it's here because it has to be. Can't be there because there's no such thing as a fraction with 3 things in it. Okay? And it can't be here, again, for the same reason. So it's this one. This fraction that I'm circling here is in the numerator of the complex fraction. This fraction is in the denominator of the complex fraction. This fraction bar serves as your division sign. So it's nothing more than this. 2x over 5w divided by x squared over 10. That expression is equivalent to that expression. And then it's exactly what we just did, right? Keep, change, flip. So keep the first fraction, change the sign to multiplication, flip the second fraction. We love this problem because there are no plus or minus signs in it, so we can just cancel freely. So we're going to do it. 5 goes into 5 one time and into 10 twice. What else do you see? X and x squared, right? So this x will cancel into this x squared and leave you with an x to the first power. So there were 2 down here, 1 up here. This one canceled with 1 down there, and you have 1. Do you have anything else that you can cancel? The 2's don't cancel because of y. Both in the numerator. Can't cancel them. They're both in the numerator. Remember, it's any numerator and any denominator where you can do your cancelings. So here we go. Let's write our answer. 2 times 2 is 4, and w times x is wx. Okay, we're going to do one more problem on this section, and then we will be finished with multiplying and dividing. This problem is going to look really mean. Eight minus 2x divided by 3x squared minus 11 x minus 4 over 6x squared. I'm going to wish I hadn't done this one. Plus 23x, especially because I don't have an answer, plus 7 divided by 4x squared minus 49. Okay, sometimes putting things over 1 helps us to see what's there. So if there is no denominator, then it's over 1. And I want to do that especially on this one because I'm going to have to change this to multiplication and flip it, right? And so I need to be able to see that. Okay, so here we go. We're going to take on this challenge. So 8 minus 2x times, we're going to flip this fraction. I'm not factoring it yet. 6x squared plus 23x plus 7 over 3x squared minus 11x minus 4 times 1 over 4x squared minus 49. Now I dropped the parentheses because it's in the denominator of a fraction now, so it makes it, it's easy to see that it doesn't need them here. I do need them because I need to show that it's this whole expression times this, not just the 2x times it. Okay, I hope I'm ready. I better stand up for this one. All right, so here, there's a GCF of 2. Agreed? This is so big, this problem is so big that I'm going to rewrite it again with the factors. I'm not even going to mark them out, or I'm just going to be real particular here. So I'm going to pull out a 2, and that's going to leave me with a 4 minus x times. I'm going to come back to that bad boy. Don't want to deal with him right now. 1 over. And again, if you want to put this over 1, feel free to on the left side there. Okay, this is a difference of 2 squares. 4x squared is a perfect square. 49 is a perfect square. It's a minus sign in the middle, so it's plus and minus the square roots, right? So 2x plus 7, 2x minus 7. Okay, I'm going to use a different color, and I'm going to come over here, and I'm going to factor 6x squared plus 23x plus 7 using the method I taught you with the x. This is a hard x problem because there's a coefficient of 6 on the x squared term. So in the numerator, I am looking for things that multiply to be whatever a times c is. 6 times 7, that's 42. And I want them to add to be the middle number, which is 23. Um, 21 and 2. Pretty easy, wasn't it? Did you catch it? I caught it when I started looking at them here before I wrote it over here, because I didn't want to mess up really bad. So remember, we set up our binomial factors. And remember, our first step is not correct. It's our scratch work step, x and x. It's a plus 21 and a plus 2. So you write plus 21 over whatever the a is, which is 6, and x plus 2 over whatever the a is, which is 6. Then you're going to reduce those fractions and then bottoms up. So we're going to reduce them first. X plus 3 goes into both of those, 7 halves. And then this reduces to 1/3. Scratch work still. Now we can bottoms up, and that will be the final answer. So 2x plus 7 times 3x plus 1. If I FOIL it out, it does match up to that. So I'm going to come back over here and write my factors in. 2x plus 7 times 3x plus 1. I have to do the same thing with this denominator. So let me come over here. 3x squared minus 11x minus 4 is what I'm factoring. If you do trial and error, that's fine. This is just my little way of doing it. Whatever works. If you already know how to factor it, you can ignore everything I'm saying. Remember, okay? I want it to multiply to be 3 times negative 4. That's negative 12. And I want it to add to be negative 11. So that's pretty easy. That's negative 12 and positive 1. First step is not right. X minus 12 over whatever the a is, which is 3, times x plus 1 over 3. reduce, x minus 4. And then this one won't reduce, so we bottoms up. 3x plus 1. Okay, I can sit back down now. I feel better. I can't see it good, really, from this angle, so. All right, now we're going to start canceling. Anything that can cancel. Oh, my goodness gracious. Look at that 4 minus x. And that what right there? What are they? That's right. When you cancel them, they make a ratio of -1, right? So they're opposites of each other. So this and this cancels, and I would just put times -1 right there. The 3x plus 1's cancel. And then this 2x plus 7 is going to cancel with this 2x plus 7. And I think that's all that cancels. So I have 2 times -1 times 1, -2 left in my numerator, over 1 times 2x minus 7. Cannot cancel the 2's because this is not a single factor down here. It has a -7 attached to it, right? This answer could also be written like this. This is the most appropriate answer. Okay,